Hi guys, so today I'm going to be teaching the difference between structured programming and object-oriented programming language. Now, when it comes to coding, these two programming language are the most fundamental methodology used to solve problems. The easiest way to understand the difference is to look at each of them. Now, structured programming is a combination of steps and functions, and each step communicates with a function. And you can see right there each step communicating with a function. And the OOP is just a mixture of data and objects. Objects are like characters, and data are part of the characteristics of an object. So let's go to structured, the core concept of structured programming language. Okay, so SP. Now you would think of SP as a recipe. It follows a top down approach. A large program is broken into smaller, manageable pieces, and your program flows from the top down to the end. And if you notice from the diagram that your flow interacts with functions, yeah, it interacts with functions, and it's kind of structured in a way because that's the name structured. So there's this particular um, formality in the flow, formality in the flow, whereby it basically follows an input process output flow. Now we're going to see that when we get to the examples. Yeah, we'll take an example. And one of the things you need to know about structured programming is basically, like I said before, structured and it takes bigger problems, bigger problems, and it breaks bigger problems into smaller problems. We have a big problem, and what structure we do when you're working with structured programming language as a method, you break down these bigger problems with a knife, if possible, or with your logic into smaller problems. Okay, so always also take subject structured programming language like a recipe. It makes it easy. Makes it easy. Alright, let's take an example. Um okay, so before we take an example, let's take the key ideas of structured programming language. What steps? The first thing you think is what step do I need to solve a problem? Now, I want to take a quick problem here. Imagine you're writing a code to add two numbers together. So, what step are you going to take? Is the major thing, and you have to look at it. First things first, you get your input and you process it and get output. And the one thing about structure is that it allows data to move around freely, from functions to functions. So if we take the same example, you see that our input would probably come after we have written the function. But it doesn't matter because it's structured, so you can call your function as much as you want to call your function. And let me digress a bit. Functions are small blocks of codes in a large, big code base, whereby it allows you to reuse that particular block over and over again by calling the function with parameters. Okay. Now let's take for example a structured program is in Python though. A structured program to add two numbers together. Okay. So the first step is would define a function. So we're gonna write def Python. Oh, sorry, add. Then you have number one, number two. Those variables you're seeing in the circle are called parameters, or like I like to call them inputs in your functions. All right, so you have return number one and number two. So we're returning an addition, and when you write a return statement in the function, what you're trying to do is you're trying to return a value when that function is called. You're returning a value when that function is called. Now, like you see in line four, we're getting the input. We're getting the input from the user that's going to run the program. So we see float input enter first number, and we know the input gives the user a prompt. Why the float function there converts the input of the user into a decimal number, a number capable of having decimals. Right, line 5, we can see num2 is equals to float input. Enter the second number, and line 6 you have our output with sum equals to add num1 and num2. Now what we're doing there, as you can see, is that we're calling the function def add, which what it does is that it returns a numerical value, which is the number 1 plus the number 2. And one thing we notice about this code is that our primary logic is kind of embedded in the function. Then our flow is always, most times, organized, which is flows from input to the process, then to the output. So it's really that structured. All right. All right. So we do a quick exercise. We do a quick exercise. You guys do it, and you can, if you want to, type in your answers in the comment section. So using structured programming method, write a Python code that can subtract two numbers together from each other. Anyhow, yeah, put your answers, your codes in the comment section. So that's all, a quick rough explanation of structured. Now let's move to object-oriented programming language. Now, OOP works like a factory simulation. Now, what I mean by factory simulation is that just like in a factory, you have workers, and your workers are like objects. So instead of now looking at your factory like a step whereby you have to deal with um, the way things flow, you are dealing with individuals that affect the flows of those things. So we deal with objects, right? In object-oriented and programming language, from the word object-oriented. So we're focusing on things that makes the flow work instead of focusing on the flow. Now, search structured programming language focuses on the flow. Object focuses on those things that are important to the flow, those things that make the flow work, those things that perform the flow of the system. Now, each object has its own characteristics. We call that data characteristics and behavior. Okay. So that's one characteristics and behavior. Um, Now, your characteristics under your object represent the data, that is the information about your object, about what this object carries. Um, we're going to move to an example in the next slide. So we have the data about the object under the characteristics. So everything you need to know about the object should be under the characteristics. And the behavior are those flows that it performs. You get what the object can do. Yes, those flows the object performs. Um, let's take for example. All right, so you are supposed to build school management software, and you want to build the school management software using object oriented programming language. Just give me a moment. With object oriented programming language. All right. So first things first, we have our objects. Now, this is just a rough sketch. So objects are important objects in Google School Management. First, we have the students. These are the ones that are, definitely what student is. Then we have the parents, then the teacher, and the school admin. Right. So we'll pick one of these objects as an example. So let's pick the student object as the main example. All right. So students. Now, the first thing we're going to write as is the behavior of the student. The characteristics. Characteristics of a student. Now, a student has a name, has a data. So the name of the student. Student has a gender, the gender of the student. Student has class of student. Student has address, definitely the address of the student. These are characters, these are the data that we need to know. Then student has guardian or aspirant, dependent as that. Now these are just simple data we need to know about um students. The one more student has a registration number, which is always special to the student. Now, this basically are the data that you need to know about the object called student, right? Peculiar to the object called student, right? Now we move to the behavior of a student. Okay, student object. Now the behavior. What can the student do? Right? So first thing, students can register. Students can make payments. Student can make payments. These are basically things the object can do. A student can check results. A student can submit assignment. A lot of um. These are just your flow of the object. Now you can see the difference between SP and OOP. It's OOP just doesn't have to give each of the okay, students can be promoted and can graduate. Now, the structured programming language doesn't give each of these objects this ability to do this, and it takes the system as one giant flow. So it's kind of limited to some things. While you see right from the way you're looking at OP, you can actually see the whole potential of how big it can help you. It makes programming easy. and it allows you to reuse some of these allows you to use some of these objects, when generating um new account or something. Like an example now, if a new student is coming to the school, um the OOP allows you to create a new instance of the object called student, whereby this instance will carry the characteristics and the behavior of the object called student. So it makes it easy, and it treats each of these objects independently. It makes it very, very easy. Very, very easy. So I guess you can see why most of our mobile um, applications, web systems are created using OOP instead of structured programming language. Yes, they're created using the OOP method. That's why you see that everybody that opens a Facebook account, a TikTok account, carries the characteristics and the behavior of other TikTok accounts, because there was an object that was created initially called a user in TikTok. So when you create a new account, it's independent of other people's account, but yet you all have the same characteristics and the same behavior. You can like, you can comment, you can change your profile picture, you can post, you get. So um I'm gonna give you a quick task now. So create a an object, sorry, an object for teachers. Yes, in school management. Write down the characteristics and write down the characteristics and the behavior of the object. So anytime you pick your device on Facebook, Instagram, WhatsApp, or TikTok, just imagine, and it's not even about you imagining, know that you're an instance, your account is an instance of a particular object in that program. Try it and drop your um, answers in the comments below. So thank you for joining me on this class. I'd love to have you again. Please like and comment and subscribe. If you have not done that, please subscribe. I'll be doing more on coding and maths and physics. It's science, tech, and designs, So like and subscribe. Then also hit the notification button. I'd love to have you again. Thank you very, very much for listening. Watch out for the next video. I'll probably be the YDX. Just please do. Bye.